Greetings, chemistry students. Today we're going to start our Unit 1 of AP Chemistry, which is Atomic Structure and Properties. And despite the name of the unit, we're actually going to start with talking about moles. So I'm just following through the units as the College Board has designed them, and that's just where they decided to stick moles. It seems appropriate, though. So the first thing to know, and you probably already do know this already, is that atoms and molecules are so incredibly small you can't actually see them. So you can't directly count them. You can't look under a microscope and count out individual atoms or things like that. But there is something called Avogadro's number, which relates how many particles you have, either molecules or atoms or what have you, to this concept called the mole. Kind of like bakers use the dozen for keeping track of baked goods, chemists use the mole for keeping track of molecules and particles. So it's a very useful way for us to essentially count particles that you can't actually see. And a mole, as you're probably familiar with, is one mole is 6.022 times 10 to the 23rd particles. Right? Now, the mass of an atom of an element measured in atomic mass units equals the mass of 1 mole of that element measured in grams. So, in other words, moles equals grams divided by the molar mass, or the molar mass equals grams per mole. If you look on the periodic table, that number written under the element is the average atomic mass of that element, and that's how many grams are in 1 mole, or 6.022 times 10 to the 23rd molecules of that element. Right? So if we look at this is a little graphic organizer that I use called MoleTown, where the relationship between particles and moles is Avogadro's number, and the relationship between moles and mass is the molar mass, the number off the periodic table. So we're going to take a look at a few examples now. All right, so let's consider the question, how many molecules is 100 grams of sodium chloride? All right, so this problem is one of the more difficult problems that you could face in a standard mole conversion problem. So we're starting with grams of sodium chloride, and we have 100 of them. Now, our first step is going to be to take those grams of sodium chloride and convert them into moles of sodium chloride, where 1 mole is, now sodium chloride is not an element by itself on the periodic table, so we need to figure out its molar mass. So we take the mass of sodium, which is 22.99, plus the mass of chlorine, 35.45, and you add those together, and you get 58.44 grams. So if we just stopped right here and did the math, this would tell us how many moles are 100 grams of sodium chloride. But the problem is asking for molecules, so we can take this one step further, and we can go from moles of NaCl to molecules of NaCl. When you set up these conversion factors, key thing to note is whatever units you're starting with, those units should appear on the bottom of your conversion. So you take what you're starting with, and then what you're trying to find goes on top. That way, when you cancel out units, because what grams of sodium chloride divided by grams of sodium chloride, those would cancel each other out. Same with moles and moles. All we're left with at the end is molecules, which is what the problem is asking us to find. The relationship between moles and molecules is always the same. that 1 mole is 6.022 times 10 to the 23rd molecules. So then we take our trusty calculator and we put this into our calculator. And I'm coming up with an answer reported, and I probably should have put a decimal point there so we can have more than one significant figure in our answer. So reporting this to 3 significant figures, that would be 1.03 times 10 to the 24th molecules of sodium chloride. Right? And we can look at this going the opposite direction. We could say, what is the mass of 5.8 times 10 to the 22nd? Let's go with nitrogen molecules. And keep in mind, nitrogen is one of our diatomic elements, so it always comes in pairs. So we start with what we're given, 5.8 times 10 to the 22nd into molecules. And our first step is going to convert what we started with, which is into molecules, into moles, where 1 mole is Avogadro's number of molecules. And then we can go from moles to grams, where 1 mole equals the mass of, and we're working with nitrogen. So we need the mass of nitrogen off the periodic table, which is 14.01. But keep in mind, since it's diatomic, there's 2 of them, so it's 28.02. And then we put this all into our trusty calculator. So 5.8 times 10 to the 22nd times 1 over 6.022 times 10 to the 23rd times 28.02 over 1. And I'm getting an answer that should have 2 significant figures in it. So we're going to call that 2.7 grams of nitrogen. Also, keep in mind when you're putting scientific notation into your calculator that you should be using the button that allows you to do scientific notation, the little EE. So you press that, and so on your calculator, it says something along the lines of like 5.8 times 10 to the 22nd, where it's 5.8 E22. So just be aware of how you put this into your calculator. What else? The other stuff I've got for you is, for those of you that feel like you need more practice on this, I have these mole practice problems where it's practice with finding molar masses and then calculating mole conversions from grams to moles to molecules, and all sorts of practice with that. And I've got a full YouTube video that I will also link that'll walk you through how to do that. So if you need more practice with that, you can have all the practice you want.